So kind of jumping into it, we all know, I think probably everybody here agrees that JavaScript is awesome, right? We all love it. And we like to talk about how JavaScript has won, and it's the most popular language, and it's kind of out there by any metric, kind of growing faster than anything else. And there's a lot of reasons for it, right? There's a lot of goodness in it, and all sorts of core JavaScript traits. Some are just sort of scripting traits, and some are specific to JavaScript around, built-in memory management and native serialization with JSON, and the fact that it's naturally scalable. Various sort of great capabilities that help us be productive, right? Helps us run faster. And those are amazing capabilities, and they're core, right? And they are indeed parts of the reason that JavaScript is so successful, and that in general we can create these awesome things. But sometimes the same capabilities that are sort of unique and make it awesome also make it vulnerable, right? So you look at these different capabilities, and while you might see kind of built-in memory management, I would look for the flaws there, and I will see buffer object kind of leaking memory from server side. If you talk about native serialization, attackers would look and they would say, well, you can do some type manipulation because types are decided in runtime. Can I manipulate those? Can I change? So a lot of this talk today is just going to be understanding a little bit about how these capabilities can be abused, right? How can attackers use them to understand the weaknesses in your system and run forward? The other thing that's important to remember is that these vulnerabilities and these types of flaws don't just happen in your code. As part of a core kind of a core part of the JavaScript ecosystem are packages, are libraries, npm in Node. It doesn't matter if you use Bower, if you use JavaScript libraries, if you just download a jQuery away, much of your code is third-party code, open source code that you are using. And npm is also awesome. And as a result, its usage has exploded. I'm kind of picking on npm, but really this is true for package management as a whole, and it has some ridiculous number of downloads and packages every time I need to sort of update the slide. And the result is that a typical application, I will focus on Node, but this is increasingly the pattern in front-end JavaScript as well, has a ton of dependencies, hundreds, oftentimes thousands. One study put it at 350 on average. And it leads to the situation where this is your app, and this is your code. And this may seem like a negative slide, but it's actually not, right? You could create all that orange value by just writing that little purplish dot, orangish value. So it's a good thing, but it also is a risky one or a slightly frightening one from a security perspective. It gives an entirely different meaning to JavaScript has won. Definitely on the dependency metrics, JavaScript is also leading the charts. So with that context, when you think about security, it's also remember to understand that most of your app's code comes from npm, which also means that most of your app's vulnerabilities come from npm or come from these packages. So it's different sources that can lead into your system. This is not a theoretical problem. It's practical. Roughly 1 in 7, 1 in 8 packages in npm carries a known vulnerability. Doesn't mean that 14% of them are vulnerable, but the packages themselves use other packages that use other packages, and within that ecosystem, roughly 14% would bring in a vulnerability with them. And we see that pretty much every Node shop has those. And this risks Node apps, and this is kind of the focus that I talk about here. But when you talk about JavaScript, it's not limited to just Node. It's also true for front-end application. With jQuery has a very prevalent cross-site scripting vulnerability if you're using a specific component of it. In React, in Angular, with Browserify, with all of these components, you pull in npm packages, and again, the same concepts apply for Bower. And it also risks the Internet of Things. So there's a lot of chatter today about Mirai, about all these DDoS attacks, massive attacks that take down the internet that are built on these devices. Many of these devices run Node apps or very small, lightweight apps, and those could have vulnerabilities. So that's kind of setting the stage. And most of the time, I'm not going to spend in presentation. But what we're going to do is we're going to try and combine those two. And what we'll do is we'll look at real-world vulnerabilities in these npm packages. I find it more useful than fabricating an example. These are real packages with real vulnerabilities that you may actually be using. And it has a bit of a dual purpose. One aspect of it is to see the vulnerabilities and how can you kind of code to not have them. And on the other side, understand a little bit the security risks you might be pulling in through those packages. And we're going to focus on Node, but as I said, this is sort of applicable more broadly. So with that, let me switch out of this and introduce Goof. So this is a JavaScript talk. Clearly, it needs some surprise. I'm the first one to have a model view control like an MVC app in a JavaScript conference. And it allows you to do great things like a to-do list to say, call mom. And it has some markdown support to emphasize important things, and just sort of some features. And it uses a bunch of packages on it. I'm going to use our tool, Sneak. It's on GitHub, by the way, and on sneak/goof, and you're welcome to clone this and play with this after and run those exploits yourselves. So we're going to use Sneak to test this application to try and find some of these vulnerabilities. Then I have some pre-opened tabs just in case it doesn't play ball as we go. So we will test our different repositories, and we will find our little vulnerable app here. And we'll see that Goof has a bunch of these vulnerable dependencies. So we're going to pick on that and expand. And I will kind of randomly choose a specific set, not randomly, but I've chosen a set of these and show a bunch of exploits. And there, each of these, there would be some explanation that says this is a vulnerable package, this is the vulnerability on it, and how it manifests. We're going to start with this one, with ST. Who here is familiar with ST? Not that many. It's a package written by Isaac from NPM. It's used to serve static resources, JS and CSS on our website, as well as our About page. And it serves static resources from the /public URL. So to attack ST is susceptible to a directory traversal vulnerability. And typically, you would read the advisor here, but you have me, so you don't need to. See if this font is big enough. So what happens is, if we have some aliases to spare instant typing, but if we go on and we do a curl and we fetch the about HTML page, we're switching to the terminal because the browser has all sorts of convenience features around normalization, things like that kind of get in the way of attackers. So we can get the about page through here as well. And as an attacker, if I know or I suspect there's a directory traversal attack, then the first thing I'm going to do is try to break out of the static file folder. These are components that are supposed to serve a set of static resources, but you don't want them to serve more than those resources. So I will put a // and if I do that, I will get nothing, actually. So if you kind of scroll up, you will see that I just got redirected to the home page of it because ST is a smart package and it has a security control on it. It's not that it didn't think about security. It just omitted something. There's another way that I can represent a dot in a URL, which is dot URL encoding. So I can do %2e, 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 and that would get me all the way up to the root, and I can do as many of those that I want. And then I might want to add some sensitive file, say like an etc passwd, and voila, I get the etc passwd. So, okay, so this is we're just getting started. Simple, simple vulnerability, and sort of prevalent enough. So we're getting warmed up. We're going to go from simple to complex, right? A vulnerability, at its core, the vulnerability that ST had here, and this is a common vulnerability we see around, is just not dealing with encoding. So you have to think about the different ways that a character can get represented in your system. So this was on the URL side, so we showed a bit of a URL encoding vulnerability. But let's look at another one in marked, which is more in the HTML side. So who here is familiar with marked? A few more hands. So marked is one of the more popular markdown parsing libraries out there, and it gets about 2 million downloads a month. It's quite prevalent. And we use it to sort of do that, emphasize beer and things like that in our system. Now, we know that it's susceptible to a cross-site scripting vulnerability. So what's the first thing we're going to do? An alert script. So we're going to try to do something like this. We'll say alert1/script. And we'll try to do this because Markdown, oftentimes, many of these packages, including marked, actually support some HTML snippets in there as well. So we're going to do this, and nothing. We're just going to get the text. And that's because marked has a sanitize function in it. Now, surprisingly or not, sanitize is actually turned off by default. So that's something to consider. Many of these packages actually have insecure defaults. So they might have a security feature. It might not be on all the time. But in this case, we did turn it on. We want it to be secure. But there are other ways to get a script onto a page. How else can I invoke a script? Thoughts? Yeah, I can do a link. So there's a bunch of these. I can also do like attributes. I can do a non-error. I'm going to focus on this, right? I might do a script like this. So I'm still within Markdown, and I will do an alert1. And then what happens here if I do this? No. Nothing, because marked catches this. And again, the sanitize function is quite comprehensive. In fact, it is fully spec compliant. So even if I try to get fancy here, and I will try to use an HTML entity. So HTML entity is kind of the HTML little sister version of URL encoding, or maybe the other way around. And I will represent this colon with a ampersand and a hash, and I think it's a 51. And also from kind of past experience, I know that I also need to encode this thing to, I think, a 40. Let me sort of cheat here a little bit. Oh, sorry, this is 41, and the other one needed to be 58. And these are just sort of ASCII representations, just numeric representations of this character. And if I do this, I'm now evading some of the security controls. And if I do this, I get nothing. So again, like security controls can be pretty tricky. And this is, on the HTML side, something that's important to understand is Market is actually fully spec compliant, and it catches these things, and there's no known exploits that are not spec compliant. But browsers, not so much. So browsers tend to be very tolerant towards HTML mistakes. And if I come here, say, after this 8, and I say, I'm just going to zoom in further, and I add the word this. So the browser sort of sees, well, you know, you said an ampersand, and you had like the hash mark, and you had 58. You didn't go all the way, but I kind of know what you mean. You know, I think you mean a colon. And they would put a colon there, and then the remainder of that is just script. And this is a valid thing to call in script, and I get a link here, and we got our alert. So vulnerability number 2. OK, so kind of first lesson from those components, you know, one is just, again, think about those, think about the different encodings, and there's the URL side of it, and there's the HTML side of it. Let's get fancier. So in both of those cases, we talked about encoding vulnerabilities, but there are other properties of JavaScript. One of JavaScript's kind of bigger claims to fame is that it's naturally scalable. Right? It is event-driven, so it doesn't require a thread for processing every incoming request. And it also means that it's a bit of a point of fragility, because if one of those threads, if there is an action on the thread that makes the thread take a long time, some algorithm, some infinite loop, like the wild truth that Jake showed before, right? If you had the wrong conditions, you get those prompts in the browser that says this script is running for too long, or you might take down a thread on the server. And because JavaScript is naturally scalable, even high-scale production systems have a relatively small number of threads. So it can quickly lead to a denial of service vulnerabilities. Now, the most prevalent type of algorithm that we run, although we don't think about it that way often, is a regular expression. It's an algorithm. It runs. And depending on how you write the algorithm, but almost always true to an extent, the time it takes to calculate or sort of apply a regular expression is non-linear to the length of the input string. Now, that linearity may be hard or may be low, so depending on your regular expression. Let me kind of switch back to the slides a moment and show you a bit of an example of this. An aptly named problem in regular expression referred to as catastrophic backtracking. So you look at this regular expression, and it seems pretty simple, right? It's just sort of A, B, C, D, E, and you could have like more of the C occurrences, and then maybe a wildcard. But what happens here is the regular expressions are very stubborn. They try to match. So if you give them a pattern, if you give them a methodology where they can almost match, like almost get there, but not quite, they will backtrack and they will try to figure out another path. And by having nested groups like this, so first, if you have multiple C's, they could apply to the C plus inside the group, or they could apply to the star outside the group. And that just creates a ridiculously large set of possibilities. And most regular expression engines, including the ones in JavaScript, would just try them all. And as a result, you can see that by just having this fairly short string there, I don't know, that's like 30-ish characters, I can make calculating this regex take a second, and then every character I add would double that amount of time. And this is on a sample machine, but it's definitely a lot of time. So Moment, a very popular package, has recently had this vulnerability. I don't have an easy demo on that one, but another package that's very popular that had it is MS. And MS is used for, do I have it here? Yeah. MS is used for calculating milliseconds, or a timestamp into milliseconds, so we can say, call mom in 2 days, and it would calculate those 2 days to say, this is the number of time milliseconds, so I can set a reminder. So MS has this vulnerability a little bit less extremely. So it also has a regular expression denial of service vulnerability, but it's not quite as extreme. So what we're going to do is, first of all, we are going to, again, kind of make this call mom in 20 minutes, and I'm going to use HTTP or HTTP, which is the same as a curl, just like with some syntax highlighting. And it goes on. If I go back to my application, I will see that I added a little bit of a record here. But what we will do is we will try to give it an especially long string. So, and again, I'm just going to cheat because I have it just to spare myself some timing here. And what we'll do here is we will print 60,000 fives as the duration. And then we're going to add another twist, which is we're going to swap the last character here, instead of being an S, to an A. So it almost matches, but doesn't quite. And when I do this, it takes a long time to respond. Now, it takes a long time to respond. It's not a problem. But the problem is that in the meantime, my application here is unresponsive. So in this case, I have a single thread, and this is just taking out one Heroku dyno here. But first of all, I can hike up my bill, and if I added another 0, it wouldn't complete before the end of this talk. Now this way, it will, I think, in about 10 or 15 seconds, complete and end. But this type of regular expression denial of service is a very prevalent vulnerability, and you have to be very careful about regular expressions, both in your content and in code overall. And now, in this case, you might say, hey, this is 60,000 characters. Who in their right mind would sort of pass 60,000 characters? But if it's not explicitly blocked, it is allowed. There's nothing really there. The fix in MS, by the way, in the package is a little mediocre. They just capped it, I think, at like 1,000 or 10,000 characters. The right solution is to have a logical cap there to allow 20 characters or 30 characters in the different sections so that you truly limit it. Because otherwise, it doesn't take down the server, but it takes a very long amount of time to process. OK, so our application will recover here. We can just kind of go back here, and we deleted a bunch of items. So this was redos, and it really comes back to the event loop. And the same types of problem can kind of happen on front end. For my last trick, I will show a couple of other vulnerabilities. So this was in MS. And the last vulnerability I will show is in Mongoose. Who here knows of Mongoose? Yeah, everybody. So Mongoose is, everybody knows Mongoose is the way to access MongoDB. It's kind of the top one. And it has an interesting vulnerability in that it tripped over an object called buffer. Now, buffer is a very, very tricky object in the world of Node. Typically, when we work in JavaScript, we don't really think about memory management, right? Memory is this thing that's just sort of handled for us. But buffer allows us to play with it a little bit and to pre-allocate some memory. And it has a couple of constructors. Actually, I went to the advisory here, but I can probably show you here. If I just run Node, I'll just sort of move this up a little bit so you can see it. And if I can do new buffer and say 100, and I will get a buffer allocated with those 3 characters, 1, 0, 0. But if I do a new buffer and give it 100, I will get 100 bytes of memory. That's intended. However, that memory is not zeroed. As you can tell here, if I do this a few times, you'll notice that you have very different values in the different items, because this is just what happened to be in memory in those 100 bytes that I just allocated. So as an attacker, if I can make the application allocate such memory and then get access to that, this is remote memory exposure. And if I do this enough times, I basically can get anything that's in the system's memory, including keys and source code and a lot of those components. This is like Heartbleed in OpenSSL, except running in the Node process, so only access to the secrets that the Node process has. So buffer has stripped up many popular packages, Mongoose included. And for us, we have a little bit of a simple schema here that allows us to, we use buffer as the content field, and so we can have images and other uploads. And Mongoose indeed had a vulnerability where it did not enforce the right type that goes into the component. So what we're going to do to exploit this is, first again, we're going to move to the browser. So we've already seen that we can do a curl command to invoke an item. But what we will do is, our application, like many Node applications, also supports another form of input, which is JSON. So I can do echo with, instead of a form field of content, a JSON parameter of content, and say, fix the bike. And if I do this, then if I go back to my application, I will see that we've indeed added an item that says fix the bike. But because this is JSON, I now have the ability to modify it a little bit. And instead of saying fix the bike, I can say 800, like this, which would give me 800 as a string. Or, because this is just naturally serializable, I can say 800, like this. When this gets serialized in the application, it allocates 800 bytes. And that memory is now a to-do item that's exposed to me. And if I look here, I will see just like a bunch of binary components. If I just do this enough, then it depends on the every demo I get something different. But you might see some snippets of text and source code. Kind of need to trust me here that if you run this enough and you do a loop, you just sort of extract those. Of course, as an attacker, you would kind of clean up after you. You would delete these items right after. So buffer has tripped many items. It's really not just Mongoose, but it's a pretty severe one because it touches on memory and allows that to sort of be leaked out. It also demonstrates a broader problem called type manipulation, which is true for any kind of dynamic typing language, and specifically JavaScript, and can happen with JSON, but also can happen in other components. A good example of that is QS. And QS, if I parse a string like this, I get a JSON object or a JavaScript object with two fields, A and B. But if I pass it two A's, I get an array. And for instance, this tripped Dust.js, which is a LinkedIn templating library that PayPal used and actually had a real-world vulnerability on PayPal because a sanitization logic only happened on strings. Nobody anticipated that an input that came through the query string could be anything but a string, but with QS, it can be. With JSON, it can be. So it's just something to be aware of to say, do you know which type is the one that you're using? And just sort of as a last anecdote is type manipulation can also be used to do something called NoSQL injection. So we've shown strings and arrays, but if you have something like this where you use Mongoose to find users by a username and a password, and it's meant to be used like this where you have an admin and a string. However, if you can control a JSON input, then you can do something like this, and instead of a string in the password, you pass it a Mongoose function that allows you to say greater than nothing, which is everything, which means that if you've done this, you just get basically like SQL injection. You get a NoSQL injection to return all the records. And depending on your application logic, this might have just been a pretty major thing. So just to cap off, I want to show you a couple of things. So before we close off here, one thing I do want to show you is, we talked about a bunch of vulnerabilities. There are clearly many, many more that we can talk about. Hopefully these give you a tidbit. And the other thing you should talk about is, on one hand, you should understand the security flaws. And on the other hand, you should understand this application has been made vulnerable without writing any of this vulnerable code. You just pulled it in externally. So, a little bit of a shameless plug. You can try out Snyk to help this, help find those issues. Free for open source, kind of try it out. And it would also help you fix those issues. Just sort of open a fix pull request with a single click, like magic. And just sort of try it out and take over, protect yourself. Going back here. So yeah, as you sort of seen when I moved the slide, don't start hacking a website. You could get in trouble. And either way, it's impolite. I will encourage you, above and beyond sort of general awareness, to first of all think about the JavaScript takeaways and these mistakes and how can you avoid them in your own code. And second is think about the specific vulnerabilities in these NPM packages. Use a tool like Snyk, like Node Security Project. There's a bunch of these tools out there to help you find those issues. Use tools to help you fix those through upgrades, through patches, through whatever means necessary. Don't discount this. This is a part of your job. This is a part of software quality, these security concerns. So to recap, JS and NPM are awesome, but please use responsibly. Cheers.